Now let us look at understanding what a rectangular hyperbola is. Again, a type of hyperbola which has been classified as rectangular hyperbola. What is it? In an rectangular hyperbola, the length of transverse axis and the conjugate axis is equal. That means, as it has been mentioned here, A is equal to B. That means if I was to write an equation, this would become x by a square, x square by a square minus y square by a square is equals to 1, since a is equal to b. So this can be one of the ways of writing my equation. Apart from that, the standard way on which I write the equation of rectangular hyperbola is xy is equals to c square, where c is a constant. This can also be written as xy is equal to c square. C is a constant. C is constant. Now, if let's say you were to find out the eccentricity of this ellipse, now it is very easy for you to find out. You know the formula for finding eccentricity in an ellipse, in an hyperbola. E square is equals to 1 plus b square by a square. So here b and a are same, so that they would cancel out each other and make it 1. That means E is equal to root 2. So for all rectangular hyperbolas, E is equal to root 2. Their eccentricity is always equal to root 2. Now if I was to draw the diagram, now I hope you all remember while studying conjugate hyperbolas, we had talked about a term known as asymptotes, lines which do not touch both the curves of hyperbola but however seem to touch at infinity. Similarly, for this type of hyperbola, rectangular hyperbola, our x-axis and y-axis become the asymptotes. Now these two axes are, which used to be the transverse and conjugate axis, have now become the asymptotes. These are asymptotes. And this one is also asymptote. And how does our graph or our curve look like? It is somewhat like this. Now again, these asymptotes, these axes do not seem to be touching our curve. However, we assume that they touch our curve on infinity. Now how would we draw our axis here? Our axis would become somewhat like this. This becomes our transverse axis. And this becomes our conjugate axis. Now I hope you all must have understood that this point is one of the vertex and this point is the other vertex. That means if I say, earlier till now for hyperbolas you have studied that the length of transverse axis is 2a, the length of conjugate axis is 2b. Now of course, since a is equal to b, that means the length of conjugate and transverse axis would be same. However, now this value, the entire length, would become a different value. And how do we write that different value? It is written as 2 root 2c. This is the length of transverse axis. Now of course, whenever we talk about standard rectangular hyperbola, we will take into consideration xy is equals to c square. Now let's look at a few more details about this thing. Xy is equals to c square. So we know, first of all, the length of transverse axis is equals to 2 root 2c. Now this would also be equal to the length of conjugate axis, of course, because they are similar. E is always equal to root 2 in a rectangular hyperbola. X and y axis become the asymptote. And now if I were to write down the parametric equation, let's say if I assume a point on this hyperbola, so this is now my hyperbola. If I assume any point on this hyperbola, p x comma y, that means it has to somehow satisfy this equation. So I can write our parametric form or parametric coordinates to be ct comma c by t. This way, if you multiply these two, you would get c square and t would get cancelled, and we have converted it into a single variable formula, which would make it easier for us to calculate. Now this is our length of the transverse axis. Sorry for that. From here to here. Let's say if you were to calculate how I came up to this, of course, since we are saying that the length is 2 root 2 c, that means this length here would have been root 2 c. That means this distance here is c, and this distance here is also c. That means the vertex is c comma c, and here the vertex would become minus c comma minus c. So I hope you are understanding this thing. Vertex is c comma c and minus c comma minus c. Since you understand that this distance is root 2c and this is also root 2c, that is why together they are making 2 root 2c. And if this is root 2c, and by Pythagoras theorem, I hope you all understand how we get both these sides to be c. This is an, of course, right angled isosceles triangle. So that is how we get this value. So we found out the vertex, we found out the transverse axis. Now, of course, the foci would lie somewhere here. And now studying about the focus of rectangular hyperbola is not into our syllabus, so we will not look into that. We just know where it is. Suppose if in JEE Mains they ask you about this, so you know where the location is, it is not going to be very difficult for you to derive the coordinates of f and f2. So the same things have been mentioned here. The eccentricity is always root 2. The parametric form is ct comma c by t, and the length of transverse axis is 2 root 2. Now one more thing that you need to remember is that I hope you all can see that the center is still 0 comma 0. So you have to remember center is 0 comma 0, vertex is c comma c, and minus c comma minus c. So whenever, if let's say you are given some type of lines which passes through the vertex, that means you understand that it is passing through c comma c, and you can put these values in the equation of that line to get whatever variables or whatever unknown values that have been asked for in the question. Now let's study chords again. Chords is no different from what we have studied in ellipse and parabola, so I wouldn't waste much time here teaching each and everything. Let's say this is our hyperbola. There is a point which has been taken outside this hyperbola, and I draw two tangents from this point. These are tangents, they are intersecting at a certain point, and now these intersecting points, let's say I draw a chord. This is known as, of course, chord of contact. Chord of contact. This was the known point to me, x1 comma y1. How do I write equation of this chord of contact? T is equals to 0. And I hope you all remember how T is written. T for, let's say, x square by a square minus y square by b square minus 1. This would be our s. For this equation, T would be written as x1 by a square minus y1 by b square minus 1. So the chord of contact's equation becomes T equals 0. And let's say if this is our hyperbola, there is a chord, its midpoint has been given to you, x1 comma y1. So the same formula that we had studied in ellipse, parabola, T is equals to s1, where 1 is what? Our point x1 comma y1. We use these values to find out first s1, t, and then we take it into this equation to find out our equation of chord. Now other way of finding chord would be, of course, the old school format. Let's say 2 points have been provided to you. The chord, you know these 2 points are x1 comma y1 and x2 comma y2, or they are, let's say, in the parametric form, which is a sec theta comma b tan theta, or a sec theta 2 b tan theta 2. Then how are you going to find it? Find out the slope. Slope is y2 minus y1 upon x2 minus x1, and then use the point equation formula to find out the equation of this line. So again, things we have studied, just a revision. Focal distances, again a thing that I had taught you in the start of this chapter. Let's say a hyperbola has been provided to you. There is a focus f1, there is another focus f2. So P is any point on this hyperbola. So P f1 and pf2, the difference would always be constant. The focal distance, the difference of the focal distance always remains constant. That means pf2 minus pf1. Of course, I will take the mod of this, since I wouldn't know where the p point has been taken, whether it is close to f1 or it is close to f2, and this is equal to 2 times of a, and that constant which we are talking about is 2a, which is the length of our transverse axis from here to here. Since this is a, this is also a, this is how we find out the focal distances of a hyperbola. Now let's look at this question to get our concepts more clear. The locus of the midpoints of the chords of hyperbola which touch the parabola is. So that means this hyperbola has a certain chords. Now those chords are tangent. This is tangent to this parabola. So we need to find out what can be the locus of the midpoints of those chords. So first, let us write down the standard equation of our hyperbola, which is x square by 4 minus y square by 4 is equals to 1. And since we know that the midpoint of the chord is something that we need to find, so let us assume that the midpoint is h comma k. Midpoint, if it is h comma k, then how can we write the equation of chord? T is equals to s1. What is our s here? S, which is our equation of the curve, it is x square by 4 minus y square by 4 minus 1. So let us use this in this equation. T can be written as x1. x1 is h upon 4 minus y1. y1 is k upon 4 minus 1 is equal to s1. So this is written as h square by 4 minus k square by 4 minus 1. So minus 1 gets cancelled, 4 gets cancelled common from all the equations. So we get xh minus yk is equals to h square minus k square. So this is our equation of chord. Now of course we need to eliminate x and y from here, so that in the end we are left with an equation where only h and k are remaining, and then we can replace it with x and y to get the locus that we are trying to find here. Now we have been said that this line is tangent to y square is equals to 8x. So I hope you all remember, if we were to find out that whether a line is tangent or intersecting or not intersecting a conic, we have to find out the discriminant by taking the entire equation into one variable, which would turn it into a quadratic, and from there we take out the discriminant and we say d is equal to 0 for tangent. So let us use that formula here. From here we can say that x is equal to y square by 8. So let us replace x in this equation. We would get y square h by 8 minus yk is equals to h square minus k square. So how can we write this equation in simplified format? So this would become h into y square minus this would become, sorry, let's take this, plus y into minus 8k minus of plus, let's say, minus, sorry, 8k square minus 8h square. So this is how we can transform this entire equation. Now we see that this has been transformed into the standard quadratic equation form, which is ax square plus bx plus c. This is our a, this is our b, this is our c. So how do we find out the discriminant? We write down b square minus 4ac. So let us take this to the next page. So discriminant can be written as b square minus 4ac. What is our b? Minus 8k whole square minus 4 into a, which is our h, and c is our 8k square minus 8h square. So let us write this in a more simplified format. This would become 64k square minus 8 4s are 32 hk square plus 32 h cube, and this is our value of discriminant. And now we know for tangent d is equal to 0 always, so this equation can be equated to 0. That means 64k square 64k square minus 32hk square plus 32h cube is equal to 0. Now we can replace h by x and k by y. So once we replace it, what are we going to get? 32x is cube minus 32xy square plus 64k can be written as y. So y square is equals to 0. And from here 32 can be taken common. So we get x cube minus xy square plus 2y square is equals to 0. This is our answer. The locus of midpoint of the chord of a certain hyperbola which is tangent to a parabola. Now let's look at the reflection property. Again, a topic which has been removed from the syllabus of JEE Mains, but still let us look at the concept of it so that if by chance JEE Mains asks you a question, you wouldn't be blabbered there, you would be able to solve the question. Let's say this is our hyperbola, this is our f2 and this is our f1. Let's say if there is a line that is appearing to be passing from the first focus. After touching the curve of our hyperbola, it will pass through the second focus. Or for the time being, it will look as if it is passing through the other focus. And then it will get reflected again. It will appear as if it is passing through the other focus. So now how can the question be asked for this type of concept? They can give you the equation of this line. So first of all, you know that this point is known to you, focus is known to you. So with these 2 points, you can find out the equation of this line. And once they say that the line that was going towards the hyperbola has been reflected, that means it is passing, or it will appear to pass through the other focus. So that means you've got 1 point here and the other point this. So by using these 2 points, you can find out the equation of this line. So that is how generally they ask you the questions. Again, topic has been removed from JEE Mains syllabus, so need not worry much about it. Requires a little bit of concept of reflection from physics, but again, very easy concept. Now let me tell you an additional information which I missed out on the parametric form. Parametric form of a standard hyperbola we had studied, let's say x square by a square minus y square by b square is equals to 1, where we had said that a would be equal to a sec theta and y would be equal to b tan theta. Now I hope you understand, if let's say this was a horizontal hyperbola, if we were given a vertical hyperbola, then how can we write x? X would now be written as b tan theta and y would be written as a sec theta. Now the concept that I wanted to tell you here is that you have to assume x and y in terms of theta in such a way, since there is a minus sign here and we know it is equal to 1 and there will be a square term. So it should be sec square theta minus tan square theta. This would be equal to 1. I hope you are understanding why we are doing this thing, because this was a property that we had studied in trigonometry, which is satisfied. So when we were talking about ellipse, what was our parametric form? It was a cos theta comma b sin theta. So basically it was cos square theta plus sin square theta equals to 1. Similarly, you have to assume x and y in such a way such that it becomes sec square theta minus tan square theta equals to 1. So there is not any need for you to remember whether what x and y I am assuming when it is a vertical or a horizontal hyperbola. But the only thing that you need to remember is this equation, and from this you can assume your x and y accordingly. So that was all for the theory part of this chapter. Again, a very easy chapter. There weren't many concepts involved. Everything more or less was repeated from ellipse and parabola. So now we'll look into some previous year JEE Mains questions that were asked, and after that this chapter, the entire conic section has been completed. So let's start with the JEE Mains previous year question.